one other way of representing coordinates is by the polar system, polar coordinates. And remember how it works. You start at 0, call it the pole. And then really all you need is one axis, which it works out, it's our normal positive x-axis. And then you come out to a point here, call it P. Well, the way we name it is by two coordinates, and it's r theta, where the r, what would that be? Well, r is this distance from the pole to P, and guess what theta is? Theta is the angle from the axis, polar axis, to that line segment there. Okay? All right. So plot a couple points here. What would 2 pi over 6 be? Where would that be? Well, you got the r is 2 units long. The angle is pi over 6, so that's 30 degrees. So pi over 6 here, and then you go 1, 2 units. So right there would be that point. So it's just that point right there. It's not the whole line, just the point. Yeah. Okay. What about 4/3, 2 pi? Again, here's our polar axis. And so wouldn't that one be, that one's kind of going to wrap back around on itself, isn't it? Because 2 pi, isn't that 360 degrees? So we're back to the polar axis there. And then 4/3, so you got 1, 2, and so 4/3 would be right about there. So that point would be right on the polar axis. All right, what about 4, negative? All right, so yeah, let's talk about some negatives. What if we have a negative angle? What does a negative angle mean in our system here, you think? It goes, positive angles go clockwise, right? And so negative angles are going to go counterclockwise, right? The positive angles are measured from this way counterclockwise. And so negative angles are going to go clockwise. So negative 3 pi over 4, I look at that as negative 3/4 pi, just to remind you. Pi is 180, so that's 3/4 of a way around 180. So negative 3/4 would be right about there. And then 4, so I would be talking this here. So 1, 2, 3, 4, so that point's going to be right about there. Remember all that? Huh? The 4 is just measured from the pole to the along that terminal side. If you've ever seen the polar coordinate paper, is circular. Yeah, it's the radius. It's r for radius. Yeah, it's basically radius. All right. Now, what would we do with this one? What about negative 2 pi, pi over 3? All right, so we've got a positive angle, so that's usually where you go first. Pi over 3 is 60, so about 60 degrees here. Maybe a little more there. So we're talking the terminal angle will be there. However, r is negative 2. Well, if I go here 1, 2, that wouldn't be right, because that would be positive 2, pi over 3. How am I going to do negative 2, pi over 3? Well, I'm going to go backwards. So along this, extend that out backwards. So negative 2 is going to go, instead of going forwards, you go backwards. You with me? So you got negative 2 right here from your pole. Okay. So that's just a reminder of that. Now, another that kind of also we could play off of that one, but let's talk about this one. Wouldn't you say then there's going to be multiple names for each individual point? Like this one, for example, I could do, what would be another name for that one? Would be 4/3, 4 pi. Because if I went around 2 pi and then another 2 pi, 4 pi, that's going to put me at the same place, isn't it? So this would also be 4/3, 4 pi. Okay? So yeah, there's multiple answers for each point, or multiple names for each point. Let's see. I did it with pi over 2. But how, for example, let's just play off of the first one here. All right, so what would be another name for this point? Well, if I go, instead of pi over 6, what if I go pi over 6 and then another 2 pi? Pi over 6 plus 2 pi. Which is 2 comma, that's 12 pi over 6, so that'd be 13 pi over 6. Okay, that's what I'm saying. Or what else could I do? Well, I could go pi over 6, and then what if I went backwards 2 pi? In other words, 2 comma pi over 6 minus 2 pi, which would be 2 comma negative 11 pi over 6, I believe. What if I did this? What if I did, all right, what if I did this? What if I went where I had this was pi over 6. So this is negative 5 pi over 6. How could I get, what point would be right here with the negative 5 pi over 6? What would this r be to get that same point? Negative 2, yeah. Okay, so all these are the names of the same point. Okay, so anyway, that's the thing you run into with polar coordinates. All right, now, let's just kind of review. Oh, this is also kind of review, hopefully. Have you done polar before? Okay. All right. So what's the connection between polar and Cartesian coordinates? Well, polar is r theta, the radius with an angle. Cartesian is x comma y. Well, if we draw them out here, say you've got the r theta point. Well, let's put in our Cartesian coordinates here. And if I do that, then this is my x, this is my y. So how are those two related? Well, of course they're related. This is theta angle. Wouldn't this be y? There's a right triangle there. So in terms of r and theta, what would x be? Well, let's do it this way. Wouldn't this be r? So wouldn't x over r, well, what is x over r? Well, it's a trig ratio, right? X over r? X over r would be cosine, wouldn't it? And y over r would be sine, wouldn't it? And so out of those, don't you see that x is r cosine theta and y is r sine theta? Yeah. So that's the connection. The x-coordinate in the Cartesian is just r times cosine of theta. The y-coordinate is just r times sine of theta. So you've seen those before, I'm sure. Okay. Now, if we go the other way, what if we know the x and the y? What about polar? Well, by Pythagorean theorem, what does r squared equal? By Pythagorean theorem, it's x squared plus y squared, isn't it? Because this is what I'm thinking. I'm thinking about, what if I have the xy and I want the r theta? Well, r squared is x squared plus y squared. What about theta? Well, that's where tangent comes in, isn't it? Isn't the tangent of theta, again, I know xy. Wouldn't tangent of theta be x over y? Yeah. And so these are to convert from polar to Cartesian. These are to convert the other way, Cartesian to polar. All right. All right, so let's change here some of these. 2 pi over 3, 2 comma pi over 3 to polar. To Cartesian. So we've got r theta, we want the x comma y. Well, like we said, x is r cosine theta. So what is that? Well, it's 2 cosine pi over 3. Cosine pi over 3, cosine of 60, it's 1/2, isn't it? The y is r sine theta. So that's 2 sine of pi over 3, right? What's the sine of pi over 3? Square root of 3 over 2? So that would be just square root of 3. So the Cartesian coordinates would be 1 comma square root of 3. So it's not that terribly difficult. Okay. So to go the other way, change Cartesian 1, -1 to polar coordinates. So this is going the other way, and so we're going to use the r squared equals x squared plus y squared, and tangent of theta equals x over y. Now, it is a good idea to draw this one out, because as you'll see, that'll from your for your theta. See 1, -1 here. So we're talking a point down in quadrant 4. But anyway, the r squared is not bad. R squared equals x squared plus y squared. So it looks like r squared is 2. So r would be the square root of 2. So that distance there would be square root of 2. What about the theta? Well, tangent of theta equals x over y, which in this case is 1 over -1, which is -1. So what about theta then? We were interested in theta, not tangent theta, we want theta. What's theta? Well, if we do, what do we get if we do this would be inverse tangent. We need to know what an inverse tangent here is. So theta. It won't always give you theta. We can call it the reference angle for theta, I guess. If we get this tangent inverse of -1, which I think it works out to be pretty nice. What angle gives you a tangent of -1? Well, if you do the inverse tangent, what do you get? It just gives you -0.785. But what is that in terms of pi? You remember what angles give you a tangent that's 1 or -1? You remember? Well, tangent is sine over cosine, so which angle has the sine and the cosine the same, basically? 45, isn't it? Pi over 4? So this is -pi over 4. Now the thing is, that may not be in the right quadrant, because remember, tangent gives you what? In a quadrant, it gives you either quadrant 4 or quadrant 1 angle. So if you're in quadrant 2 or 3, you have to adjust it, but in this case it's fine. That would be just fine, wouldn't it? -pi over 4 would put you right there. So theta, we could say, is pi over 4, -pi over 4. So square root of 2, -pi. All right. So it's just a couple of quick review things. I can't go over all the things, but let me show you this one. One more, because you can. Okay. What about this one? -3, -2 to polar. So we're talking -3, -2. Right there. Quadrant 3. Change that to polar. Okay, well, r squared is x squared plus y squared. So that's r squared equals 9 plus 4. That's 13. So that would be the square root of 13. Is r. Then the tangent is x over y. So tangent is 3/2. If I do the inverse tangent of 3/2, what do I get there? Yeah. The inverse tangent of 3/2. 1.5. Did I do that right? Oh, no, I didn't do that right. It's y over x. Oh, shoot. Did I put... Did I put it wrong a while ago? It's y over x, sorry. Yes. Oh, crap, too. I'm seeing something else, too. Curses. As they say. I'm not showing this whole board, so cut it off right there. Please go back and change that. I'll have to redo this. Tangent is y over x. R squared is x squared plus y. Go back to your notes. Flip back if you took them. Tangent is y over x. Tangent of theta. Which didn't make a difference there, but it makes a difference here. Tangent is 2/3. So if we do the tangent inverse of 2/3, that's a different story. 0.588. Now, here is a big thing. Would 0.588, that's where saying is our angle, reference angle, because here, where is 0.588 going to put you? Well, this is pi over 2, which is 1.5 something. So 0.588 would put you right along in here. That's not the angle I need, is it? So there's a couple ways I could do it. Thoughts? I could say that angle and then do negative r, couldn't I? Or I could say that's my reference angle. This is 0.588, so what would that put theta at? Well, it would put it at pi plus 0.588, wouldn't it? So let's do that. All right, so theta is, r is square root of 13. Theta is pi plus 0.588. With me? Or we could say, what do we say? You could say, 0.588, but then do a negative r. That would get that same point, wouldn't it? It's just from the tangent inverse. I just put it in. Yeah, it's that angle. It's radians. That's radians. In radians. You know, pi radians, 3.14. 3.14 radians is, pi. Okay, there you go. It's radians. And then pi over 2 would be here, which, yeah. Okay. But all that's just kind of review.